Hello guys, welcome back to my channel Algorithm Mind. In my channel, I teach programming skills in MATLAB, Python or R programming. I also teach theoretical as well as practical programming skills in data science. So I request you to subscribe to my channel and hit the notification bell icon button. So I have been publishing series of videos regarding MATLAB programming. This is in this series of video, I will teach you about the basics of MATLAB programming. So this is specifically designed for those people who actually don't have an idea how to write a code in MATLAB. So we will go through a series of exercises, hands-on exercises, which will teach you how to write your code in MATLAB, and it will give you the specific understanding about different functions of MATLAB, how MATLAB environments operate, and how you can actually from this foundation can work on towards your project. That being said, so in today's lecture, we are going to discuss about how we can actually solve differential or derivative equations using MATLAB. So I will teach you step by step from the basic to the very end, where we'll be solving an ordinary differential equation. So it will be highly resourceful tutorial video for those people who are specifically in the field of numeric computing or scientific computing. So let's move on and actually discuss about our today's topic. So MATLAB provides the diff command for computing symbolic derivative. It in its simplest form, you pass the function you want to differentiate to diff command as an input argument. For example, we are interested in calculating the derivative of the function f, which is a function of t, such that 3t squared plus 2t minus 2. So if we don't, first of all, we are going to create a symbolic variable. And if you don't know about how to create symbolic variable and how to declare a symbolic expression, I suggest you to go and watch my previous video where I teach you about how to solve symbolic equations in MATLAB. That being said, in order to define a symbolic variable, we will use this MATLAB statement symt to declare a symbolic variable t, and you can also see here t is stored as symbolic variable in MATLAB environment. Once you've done that, now you will initialize a variable named f, and then you will define your expression in the terms of t. So we have t static t power 2 plus 2 static t power t minus 2. So this is the expression we have. Now in order to calculate the differential of this equation, we will simply pass f, which is our expression, to this diff function as an input argument. Let me just run this block of code for you. Run. Now you see that this expression have been derivative with respect to x, and we actually get the derivative of the function, which is 6t minus 4 by 6t power 3. Now let's move on and do some couple of exercises so you can actually understand the concept more accurately, and let's move on to different exercises as well. Okay, so remember that in order to do symbolic calculation, we first have to declare symbolic variable by using this MATLAB statements. Once we done that, we are going to initialize a variable named f, and we are going to equate its value by writing this expression, which is in the form of x. Okay, x plus 2 multiplied by x power 2 plus 3. Then we will derivate this function with respect to x, and you can see that the value of derivative is 2x x plus 2 plus x squared plus 3. In the same way, we can write more equations, for example, that has square root in it, that has polynomial term such as t square in it. So we have an expression in the form of t symbolic variable, and then we differentiate this expression with respect to t. So let me just show you the first expression here. Now you can see that f is in the form of t expression. Then we will derivate this expression by using this function and passing f as input argument, or the expression as an input argument. Now you can see that we have actually taken the derivative of this equation. In the same way, if you have like higher or degree polynomial terms, like in the form of x power 2, x power 3, x power 4, you will first define the expression here, Then after defining the expression, we will use diff function of MATLAB and pass input argument the expression you have declared earlier, and it will calculate the derivative of it. And these are same the exercises. Okay, now let's move on and actually try to be something creative with the exercise. Okay, so we are going to write a program, and basically we are going to see whether this y we will first derivate this y and 2 times. Okay, and then we form a expression based of those y, and we want to say whether left hand side equation is equal to right hand side equation. So basically what we are doing, first of all, we are declaring y as a function of x, where y will be a symbolic expression of x. Once we done that, we will calculate LHS. Here is LHS, which is equal to the derivative of y 2 times the derivative of y plus y. Okay, so this will evaluate the equation. And once we done that, we want to make sure that this left hand side is equal to right hand side. We will check and we will use if else statement, which I'm also going to teach you in my upcoming lectures. So don't be overwhelmed by if and else statement. If you don't know about if and else statement, it's okay right now. In the upcoming videos, I will teach you about if else statement as well. So we have expressed y as an expression of x. Then we have evaluated by using diff function. And if you recall that, we can also perform symbolic calculations such as addition, subtraction, multiplication on symbolic variable. And this is exactly what we have done here. Then we have left hand side and we have right hand side. So we will write if is equal left hand side and right hand side. So basically this is equal will actually evaluate whether the input arguments which are given like LHS and RHS are equal or not. Okay, if it's true, it will return a logical true. In that case, if statement will be executed, and if that's false, then if statement will not be executed, else statement will be executed. So once we run that, we see that no, the equation doesn't hold true. It means that this left hand side equation is not equal to right hand side equation. So let's move on and actually display the value of left hand side. So we can use this function, and we will pass input argument value of the HLSCs, then comma this LHS. Okay, so this way the value of LHS is minus 168 cos 5x, which is not equal to right hand side equation. So that's how you can actually do some creative works in MATLAB environment, or write your own code or program in MATLAB and execute it. Let's move on and let's work on actually finding the maximum and minimum of a curve. Okay, in order to find the maximum or minimum of a function, for example, if you have a function where y is equal to f of x, so okay, so y is a function of x, we differentiate y with respect to x, then solve the equation. So this is exactly what we are going to do right now. So for example, we have y, which is a function of x, where 2x cubed plus 2x squared minus 12x plus 17. So in order to do that, first of all, we are going to create a symbolic variable x. Then we are going to define the expression here. Once we define the expression, we are going to use an interesting function of MATLAB, which is easy plot. Okay, what it does actually, it plots the symbolic equation or an expression in a quite entertaining way. So now you can see that we have actually plotted the function, and this is the value on x-axis. We have x-axis, and on y-axis we have the value of y, and this is the plot we get out of this symbolic expression. So basically what it will do, it will just take out some random values of x within a given range, and it will plot the values of y. So that's an interesting plot we get out of it. Now let's move on and actually discuss about how we can actually calculate the maximum or minimum of this function. Now you can see that we have actually some curves in it, okay, which will define the maximum and minimum. So in order to do that, first of all, we are going to differentiate this equation or this expression with respect to x. This is exactly what we have done here, where this derivative is stored in the variable g. So g is equal to 6x squared plus 6x minus 12. And once we done that, we are going to solve it for x. So we can easily solve a symbolic variable by using solve function. So now you see that we have a value of -2 and 1, where we have the value of y as maximum and minimum. That being said, let's move on and actually discuss an interesting topic which is very important for students or researchers who are actually working on numeric computing, numeric simulations. Okay, so the physical world which we live in, where physical phenomena happen, we tend to capture that physical phenomena in the form of equations. Sometimes these form of equations can be in the form of derivative. For example, if you want to study the effect of one parameter with respect to time, then there will be a derivative involved in that equation with respect to time. So in that case, we want to solve the equations in the form of derivative. So MATLAB provides the dsolve command for solving differential equations symbolically. So we have like dsolve, and then we pass input argument the equation, where equation is a text string used to enter the equation. It returns a symbolic solution with a set of arbitrary constant that MATLAB's label C1, C2, and so on. So in order to get a accurate solution of that derivative equation, this is what we are going to use. We use dsolve, then we pass input, first input argument, the derivative equation, then we will define the conditions for that derivative equations. Okay, so derivative are indicated with d, like df. Higher derivative are indicated by following d. So d to y, so that by d to y it means that 2 times derivative of y. That's how you actually write the derivative equation. So for example, let's say this symbolic expression here, we derivative of y. Okay, so dy, then we have y static dy. So dy by dt is equal to 5y. So this is the symbolic equation we get. We put it into dsolve function. So once we put that, we get the following solution: c1 e power 5t. Okay, so derivative with respect to time. So this is the solution we get. Now if you recall that I told you that but instead of getting c1, you actually want to calculate the actual values for that derivative for specific conditions. So this is how you can actually define conditions for dsolve function. So we will write dsolve function, and the first input argument will be the equation we want to solve. This equation is 2 times derivative of y with respect to t minus y is equal to 2. So is equal to 0. So this is the equation. Now the condition is such that at y0 we have -1, and then the second condition is dy0 is equal to 2. So once we have given that, it will actually solve the derivative equation based on those conditions, and it will give you the final answer here. We just run this code upload here. So now you can see that we have got exponential t divided by 2 minus 3 exponential minus t by 2. So that's how you can actually solve our differential equation with a set of conditions in MATLAB by using dsolve function. That being said, let's move on to the final topic of this lecture, where we are actually going to solve ordinary differential equation. An ordinary differential equation contains one or more derivative of dependent variable y with respect to single independent variable t, usually referred to as time. The symbolic math toolbox includes an alternative method for solving equation, therefore is covered in this lecture. For example, this is a second order ordinary differential equation. For example, we have 2 times the derivative of y with respect to t or x is equal to 9y. In an initial value problem, the ordinary differential equation is solved by starting from an initial state using the initial condition y naught as well as the period of time over which the answer is to be obtained. So for example, this is the period of time from time initial to time final. The solution is obtained iteratively. The final result is such that audio solver results a vector of time steps t0 to tf, where this is the time range we have defined. So because in order to differential equation, we have like a solution or answer in the form of time. For example, the solution at time 1 to the time solution at time final. So this is how you actually do that. So for every time you will get a specific solution which is denoted by y naught, y1, y2. So the benefit of using MATLAB is such that you can define number of derivative equations in MATLAB. You can specify any number of coupled ordinary differential equation to solve. For example, we have here derivative of y1 with respect to t is equal to y2, and derivative of y2 with respect to t is equal to y1 y2 minus 2. So that's how a coupled ordinary differential equation can work on MATLAB. For example, a function my ODE will encompass these equations. So in order to solve the ordinary differential equations, a coupled ordinary differential equation, you have to define those equations in the form of function. And if you don't know about how to create your functions in MATLAB, don't worry. I'm going to publish a video about function that is specifically related to functions, where I will teach you about how you can create your own functions in it. So stay tuned for that video as well. But right now, this is just keep that in mind. This is how you declare a function. Then name the function. Output is equal to function name. Then pass the input argument, which is again in the form in our calculation will be the time and variable that has been studied, which is y. So this is how dy1, dy2. So derivative of y with respect to 1, dy1 and dy2. These are the two equations, and y2, and this is how you actually write it. Okay, for derivative you have dy, for variable you write y. In the same way, you can write higher order derivative equations. For example, dy dt 1, dy dt 2, dy dt 3. So we have y2, y3, y1 into y3 minus 1. So this is how you can actually write a derivative equation, ordinary differential equation in MATLAB, and define in a function. So how we are actually going to solve those coupled ordinary differential equation? We are going to solve it by using ODE45. ODE45 performs well with most ordinary differential problem and should generally be your first choice of solver. However, ODE23 and ODE113 can be more efficient than ODE45 problems with looser or tighter accuracy requirement. So this is the generic notation of using ODE45. So for example, here t, it will this whole calculation will generate two results. First one will be the time values, where it starts from 0 and with a specific interval it ends at time final. Then we have y final value, which is actually the result of our differential equation, or which is the result of y variables. You will write ODE45, then you will pass the function where you have actually defined the set of equations. Then you define the initial condition, then you define the boundary condition. So that's how you define ordinary differential equation in MATLAB, and that's how you solve it. So I'm going to create a separate script for this purpose. Now you see that we will follow the same methodology and format. So we have like t comma y as the solution is equal to ODE45. Then we define VDP, which is the set of ordinary differential equation. Here is the set of ordinary differential equation for van der Pol equation. Vy by dt 1 dy by dt, that is the second ordinary differential equation, and this is the set of equation here we have, and we have declared in a function. So once we done that, we are simply going to pass this function into our ODE function by using this @ sign. Then we will pass initial condition of y variable, and then we will pass boundary conditions. Okay, that being said, we are going to run this, and once we done that, we are actually going to plot the values of the result by using plot function here. So we have like plot t comma y colon means every value of y, and 1 will be the y1 solution. Okay, it's because if you see that we have two variables of y1 and y2, and in the second we will plot on the y2 on the same plot. And let me just run this block of code for you, and you will see that the result is quite interesting. It will take some time to solve ordinary differential equation, and once we solve that, now you can see that it has plotted solution for van der Pol equation where mu is equal to 1, and we have a solution of ordinary differential equation, something like that. So I hope this tutorial have been helpful for you. If you have any questions regarding differential equations, how you can solve numeric computing in MATLAB, numeric simulations, feel free to write down your comments. I will be happy to help you out. In the upcoming videos, I will be posting about how you can solve functions in MATLAB, how you can use integrations in MATLAB, how you can use loops in MATLAB, if-else statements. So I request you to subscribe to my channel and hit the notification bell icon button so you can get the notification as soon as I post the video. Thank you for joining me, and I will catch you soon in the next video.